Okay. So apologies in advance. This is not a live stream this week. I had another obligation that I could not set aside for this evening, so I apologize to you. I'm actually recording this a couple of days before the normal live stream meeting. That's why you see the message at the bottom. So I will be back as normal for the final week of class, but I apologize that this week I'm not actually here live, but I am doing my normal routine. So we'll talk about new content, we'll review the lab, and then we'll talk a little bit about the fourth project, which is due uh, this coming Sunday, December 11th. I can see my little cloth in the background is not quite cooperating, but we'll just have to. Let's see if I can fix it. There we go. I fixed it. Okay. Anyway, so that's what's going on. I had another obligation. I could not get out of it. So apologies that this is a pre-recorded class. All right. So we are in, at long last, the last week of the semester. This is week. Let me get this. All right. That seems pretty decent. So this is week 16. We are doing one of the, I think, maybe sort of more challenging mental exercises this week. We're not doing any new programming concepts other than we are looking at a new way to combine some of the concepts that we've learned into a single entity. So you can see at the top of the agenda, it says composition. And then I have a note there that says we need to start asking the question. And this is when you look at code and you look at something in your code, the way to solve this puzzle is whenever you're looking at something in code, ask yourself, what is this? So the kinds of things that this can be, when we say, what is this? It can be a data type in code, right? So we can see the word int, string, float 64. If we create a new struct definition, and that becomes a new type. So sometimes the word that we're looking at on the screen, when we say, what is this? It is a type. Sometimes we are looking at a variable. Because we declare variables, we create instances of structs. So we're looking at an X in the code, and we need to ask ourselves, what is this? What is X? And if it's a variable, then we usually ask, what kind of thing is it? So what is X? Perhaps it's an integer. Why is that important? Because that tells us what we can and can't do with that thing. We can't get the length of an integer like we would get the length of a string because integers don't do that directly. Just like we can't, if we're looking at a string and we say, what is this? It's a string. Well, we can't do math with strings. We can't divide one string by another string. That makes no sense. So anyway, it's a very helpful thing to do when we start sort of combining techniques and make more composite items and more composite types as combinations of other types of things, is to constantly look at what you have and ask yourself, what is this? So last week we did methods. So we have, say, item 1 dot toString. So we have to sort of ask, what is this, all the way across a line like that? What is item 1? It is an instance of a struct. What is toString? Well, it must be a method because the only thing that has a word in parentheses behind it and a dot in front of it and a thing in front of that would be a method. So anyway, we'll look at this in code. I'm really just sort of bringing that up right off the start. I'm going to be doing that a lot today, is saying, now what is this? And knowing what this is, what can we do with this in code? Okay, so week 16, the other big event this week is that the fourth project is due. So I will, as a part of this video, this lecture, go look at project 4. You have everything that you need to do project 4 without any of the new material that I'm going to cover today. So as of last week, you had all of the tools you needed to complete project 4. You have all the skills required to do that. But I will go maybe give you a couple of hints just to get you going if you haven't started the project. Hopefully you have, because we are now starting the third week since we finish the last project. Please don't wait till the last second. This is a harder project than it looks like for some people, and it's a lot harder if you are hurried at it. Okay. So let's go just step through the module like we always do and get a bead on what's going on this week. So we're going to be doing a couple of new things. So we're going to use or create and use what are called nested structs. And that's really where you define a struct, and as a part of that struct, you nest another struct inside of it. This is a way to create more complex things from more simple things. And you'll see a couple of different examples of that. What I do here in lecture, and then also when we look at the lab, is another example of where we are nesting structs. And please don't forget that important question to constantly ask when you are looking at code is, what is this? So we'll declare structs that contain other structs as a part of themselves. We will create and initialize structs with nested structs inside of them. We will access the instances of nested structs. We'll do all of those things. Another way that we will explore creating more composite types today is by putting slices or arrays inside of structs. So we can actually make slices or arrays of struct instances, but we can also include slices or arrays as a part of what a struct is. And I'll do some examples of that hopefully you can relate to. And then the last thing that we're doing this week is we are looking at, well, how do I take my ever expanding main.go and cut it up into smaller parts. We like smaller parts as programmers because it's a lot easier to work on a smaller part of a problem than to try to conceive of the entire problem top to bottom in one place. So we will look at how do we actually get parts of our code separated out into additional files so that we can, when we are doing our programming work and we are looking at a file, we can constrain our activities to a particular part of the problem in that separate file. It takes some getting used to. It's the way that everybody in the real world does it. The advantage of separating out parts of your code into other files is that you can take those other files and use them in different projects. So one of the aspects of becoming a software engineer is figuring out how to create libraries of code that are reusable and placing them in a file, and then you can share them with other people or sell them if you're lucky to other people, that they can then include those files in their own projects and use that focused part of your code to solve part of their problem. We'll explore an example of that. Okay, so just a couple of readings about nesting and putting slices or arrays inside of structs. Homework as always. The lab, which I will come back to because we won't leave without looking at the lab and at least getting some tips about how to solve it. So discussion, this is the next to last week of the semester, and we have been kind of building up toward the last week of the semester where we do what I call a C++ boot camp. So the last week, week 17, we don't have a final. We have one last round of homework, lab discussion. And it is a chance for many of you who might go on to another programming class to be exposed to the C++ language. We will compare the same software written in Go that you will, of course, recognize because you've been working at Go for a few months now. We'll compare that same software as implemented in C++ and then sort of introduce you to the C++ syntax so that you don't feel unprepared to move on to the next programming class in the sequence, which probably will use C++. So that's why we've been having discussions about programming paradigms, sort of considering whether or not Go is object-oriented or not, which is debated. But I think you'll see when we do the boot camp in the last week of the semester that everything that you've learned in Go translates over pretty well into C++, so that you will find that you are up and running in C++ pretty quickly. And then reminders, so homework lab discussion as always, and then the final project for the semester is due on December 11th, which is the coming Sunday. And then we have the one more week of content, C++, the week after that. Okay, so I'm gonna go back to the lab, and then I will open up a REPL and we will do some nested stuff. Okay. It's weird doing this just as a recording because I'm so used to having people to help me on the chat. So hopefully I don't make a big mistake and have to do this over again. Let me create a REPL for this. I will share a link to this REPL as I normally do in the lecture page for week 16. So you'll have access to all of these examples that I'm about to create in the Go language. Okay, so we will get a little bit of reviewing of how structs work as we go along. But let's create a struct type. And let's do something that I think you'll relate to. Let's make a struct to represent a student at a school. So the student will have a name, and I'm actually going to do a little bit of exploring of what it means to capitalize and not capitalize things. It may not matter, but I will tell you in advance that when in doubt, capitalize the thing until you get more experience. In the Go language, things that are capitalized are kind of automatically available everywhere, and things that are not capitalized are not necessarily available everywhere where you might want to use it. So I don't think it's going to make a difference to us today, but let's go ahead and just say let's all be in the habit of capitalizing things, and I promise you will save yourself pain. At some point, if you continue working in Go, you will learn how we use upper and lowercase letters, capitalized and non-capitalized things to actually restrict access to parts of our code. We talked about this in week 15. So every student will have a name. Every student, let's give them a street. Let's give them an apartment number. Let's give them a city. Let's give them a state. Let's give them a zip, which we can do as an integer. Although if we do the 9-digit zip with a dash in between, we might want it to be a string. One of the decisions that sometimes you face is that you need to store a sequence of digits, which if they're all only digits, then it would make sense for that to be an integer. Because that's what it is. But sometimes we don't need the integers as integers anyway, so we're not going to do any math operations on a zip code typically, so it's safe to store it as a string. But also, if you've ever noticed, sometimes zip codes are actually represented as 5 digits followed by a dash followed by 4 digits, and in those cases it has to be a string because that dash in there. So anyway, that's why I chose a string in this case. Name. Let's give the student an ID, which will make an integer. In that case, I'm going to assume that the ID is just an integer and would only ever be digits. And I don't know if math would be involved, but anyway, I think that one's safe to be an integer. All right, so there's a student struct. Pardon me. And I want to go immediately to the idea of nesting structs inside of structs. So for now, we're just going to look for where... Don't worry a whole lot about the utility of the thing. Like, why did I even bother myself? Because people often ask that question. Like, well, it didn't make my code less complicated to me. It made it more complicated to me. And that's going to be true a little bit. we're going to do some things that make the code feel more complicated. But you will find as you gain more experience that the kinds of decisions that I'm going to demonstrate for you today in terms of the way you set up your software will often allow you, and hopefully I can find an excuse to do this, this will often allow you to add sort of new features to your code without adding very much new code. In fact, I just thought of a way to do that. So anyway, it's going to feel like I made it more complicated for a bit. I'm just saying, just let that be for now and wait and see how we might use what appears to be something that's more complicated to our advantage. So here's what we're going to do. I see this street, apartment, city, state, zip as an address. So I think to myself, well, just based on my own experience, if I have this kind of thing that's complex on its own, like an address, I'm probably going to separate it out into its own component. So I'm actually going to take all of these pieces that represent the address by itself and make them their own struct. Okay, so that does introduce the problem, though, is that how do I then associate an address with a student if I just took all of the address information out? And the way to do that is to nest the address struct inside of the student. So I will call this a home address, and I will put an address struct inside of the student struct. So now this whole address thing is a part of the student, but as an extra kind of layer. So this is a nested struct. This home address will be an instance of an address nested inside of the student struct. So this is a good time to sort of practice a what is this exercise. What is this? And we're going to just do it here specifically. So what is home address? Well, I can see right here on this line of code that home address is an address. And then I ask for an address. So what is this? What is address? And I scroll up on the screen and I realize, oh, address is a struct that contains these various fields inside of it. So anyway, try to practice this process of asking what is this? What is student? It is a struct with these fields inside of it. One of the fields looks a little bit weird, so I have to ask, what is this thing, home address? Well, what it is right next to it in code. It's an address. What is this in terms of the address? It is yet another struct. So address is a struct that is nested inside of the student struct. So let's make an instance of student and see how this works. And I'm just going to go with the var. We better not call it that. Let's call it oh, I don't know. I'll call them student one. Hopefully that. So there is an instance of the student struct. And we can do some what is this questions on it. So var is the keyword that we use to create variables and instances of structs. Student one, what is that? Well, that is always in the Go language the name or the label that I have chosen for this particular variable or instance of a struct. What is this student? This is the type that student one is a variable of. So student one is a student. What is a student? It is a struct. And it has these fields inside of it. Okay, so let's populate it a little bit. So we know we didn't do a whole lot of it, but we can use student one dot, and we can access the fields directly if we want to. So we can say dot name. We did this with methods last week. For starters today, we're just going to use the fields themselves and not methods. So notice there's no functions. There's no weird receiver looking things in here like we did last week. This is just this instance student one. I'm using the dot notation in this case to access directly a field inside of the student one instance. And I'll give it myself. So I'll be student one. I will give myself an ID. All right, so now we come to the address. There's a couple of ways that we could do this. So how do we get an address associated with student one? There's two ways I could do it. So one way I could do it is I could do this. I could simply say var address one, which is an address, and then I can populate it. So address one dot street equals, we'll say 123 Main Street. Address one dot apartment. 1B, let's say. Address one dot, what all are the fields? City, state, and zip. Go to Oroville. State. I'll just put the 2-letter. Oops, that's a string. Be careful. So sometimes you see zips like that, right? And then I can take that address and I can say, well, it's student one dot home address equals address one. So now I have created the address, I have populated it with data, and now I have associated it with the student. So that's one way to go about it. And it's a perfectly fine way to go about working with a nested struct. So address being nested as part of the student struct. I create it, I populate it with data, and then I attach it to the home address. So this address one is now the home address of student one. So that's all fairly straightforward, I think. Now, one of the cool things we can do, and I'll do this and then show you the other way that we can get data inside of the nested struct. So since we have this address, we're not just limited to a home address. We could have a mailing address associated with the student that perhaps is different from their physical home address. And now we're starting to enjoy one of the benefits of having separated out the address, is that I can actually have two different address structs associated with the student with two different sets of information, which I think is pretty awesome. Okay, so let's now do the mailing address part for the student. Then I'm going to do it in a different way. So I'm going to do it this way instead. What did I call it? Mailing address. Okay, so now let's do a what is this and look at a different way to go about this. So I'm actually, instead of creating a separate address struct here and populating it and then placing it, writing it into the student, I'm actually going to work directly inside of the nested struct, inside of the student instance. So how do we do that? Well, we do a what is this kind of process. So student one, what is this? I have to scroll up and figure out by looking for the moment when I declared it. So here's where I declare it. So student one is a student. So student one is a student. That's what that is. What is mailing address? Well, I have to already know that student one is a student to figure out what a mailing address is. So given that student one is a student, what is mailing address? So I have to go find student, here it is, and then figure out from there what is a mailing address as a part of a student. Well, the mailing address is an address. So this whole thing is an address. It's a mailing address, which is an address, which is a part of a student, an instance of a student struct. So you see a lot of those kind of what is this kinds of questions. What is this? If I highlight the whole thing, what is this? It is an address. Okay, great. So what can I do with addresses? Well, I go up and I find out. Here's what addresses can do. So street, apartment, city, state, zip. I know that if I have an address and I use a dot, I can get to those fields. So I have an address. I can use a dot and I can get to the fields. which people find a little bit off-putting most of the time at first. But you have this sort of chain to get to something. So, oh my goodness, so I have to get the student instance, and then I have to get the mailing address that's inside of the student, and then I have to get the street, which is inside the address, which is inside the student, and that's all true. But you will get used to it with a little bit of practice. So the street, I don't know where to, we will let them live at 555, I don't know, University Avenue. Oops. So, mailing address dot apartment. Yep. We'll say like, I don't know, 3434. I just made it up. That's the apartment number. One. Mailing address dot street city. That in Chico, student one. Dot state, also California, student one dot mailing address dot zip. I don't know what it is. 98888 without the dash part. So how you work with nested structs is a matter sometimes of necessity. Sometimes you are in a situation in your code where you have no choice, possibly, but to perhaps create an address and then write it into the struct instance. Sometimes you may find yourself where the easier choice, or the choice that is necessitated, is that you use the student struct, the dot notation to access the nested struct instance, and then the dot notation to get the field of the nested struct instance. So anyway, it's good to practice them, to get used to sort of reading the code, asking what is this, and answering it constantly. What is this? We can do this exercise, by the way, just on this one line of code as an example. So what is student one? It's a student. How do I know that? Because I found where the student was actually declared. Student one is a student. Great. What is mailing address? Well, I have to already know that student is what student one is. It's a student. So if I go to student and I find mailing address, I discover that here in student, mailing address is an address. Great. So now I can figure out what is this on street. So street is something to do with an address, which is nested into a student. So now, since I know this first two pieces give me a address, then I can go to street in address. Here's address, here's street, which is a string. So taken all at once, student one dot mailing address dot street is a string, and which means I can do anything that I could do with any other string to it. I can assign strings to it. I can also do this, by the way. It's going to look yucky, but I can do it. So knowing that this is a string, I'm going to have to import the strings package to do this. Knowing that this is a string, I can do string things to it. I'm going to go down to the next line. So strings dot to, is it to upper? Maybe. Student one dot mailing address dot street. I'm just going to all uppercase it. So let me separate that out so it's easier to see. So since I know that that chain, student one dot mailing address dot street, gives me a string, I can do things to it that I could do to any other string. So for example, I can uppercase it and then write it back over the top of itself. So now that it is all uppercase letters. At least I think. Let me run this and make sure I haven't made any giant mistakes. Okay, yeah, so it doesn't like that I haven't used fumped yet. That's coming up next. So there is a nested struct. and I've actually used, I've taken advantage of the fact that I separated out the address, because now I can very efficiently associate not only a home address with the student as an instance of the address struct, but I can also associate a mailing address, which might be different, as an instance of the struct, as part of the student record, as it were, which is pretty cool stuff, I think. All right, so now let's introduce a method into the mix and see what the implications are of having nested things together. So I am going to make a method for the student. How do I know it's going to be a method? Is because it's going to have a receiver. And I recommend that you just, life is easier if you just make your receivers always be pointers. It's rarely, if ever, in this class at least, going to cause you any trouble. And but not using a pointer as a receiver sometimes will cause you a problem. So life is easiest if we just make all the receivers be pointers. Then we will avoid mistakes where pointers are required and we didn't have them. So if we always use pointers, then we never have the should have been a pointer mistake. Okay, so how do we stringify a student? Well, we're going to return as a string a formatted string. Let's see, so we want their name. And we'll put their ID number just after the pound sign. And then maybe a new line and all. Ooh, okay. So we're going to need, yeah. So let's do it this way. Output. We're going to have to build up some output. So we will start simply with the name and the ID on the first line of the output. This is s.name and s.id. And then we will concatenate. We will grow the output to include more. Now I put a new line after the first part, so this everything that I add to the output, which is what the plus equals will do, is add more to the output. Will be on the next line down. So I want to print the addresses. .sprintf. I want to print the addresses, and it would be the street address, apartment number, that's going to be one line of the output, so it'll be s dot, well, we'll have to do the home address first, so we better say home, apartment, yeah, let's just put it all here, city, state, space, zip, and then I'll go to the next line down so it's not nearly as nasty looking. So we'll have the s dot home address dot street, s dot home address. So notice I'm using the chain again. So I have a student. I need to get to the home address field, knowing that the home address is an address. I then access the street. Next, I will address the apartment. And then I'm going to go down to the next line, continue after that, and then I will do the, let's see, the D. So this is the street, the apartment, and then city, state, zip. S dot home address dot city, home address dot state, S dot, I'm getting pretty close. Okay, it fit. I'm going to live with it. Well, I got to keep going because now I got to do the mailing address. But here I'm going to stop and make a better decision for myself. So I have two addresses to print. I have to print the home address, and then I basically have to repeat just about everything except for the label will say home mail or something like that. So I'm going to have to repeat this whole process for both addresses. So as I'm learning to be a software engineer, I'm looking for chances to kind of scale down my coding effort as I scale up my ability to manage more information. And what I mean by that is if I'm about to do the same thing, if I'm about to do the same thing to an address struct twice, the better way often to do this would be to create for the address part specifically its own method. So I'm going to do that here. I'm going to say func a star address to string, and then I'm going to do all the work of printing an address here. And I'm going to go ahead and steal my effort, so I need all of this stuff. And I'm missing a quote somewhere. Yeah, missing a quote. I don't like the way this has aligned itself, so let me go back. Better. If I go back and do that again, does it? Okay, better. So anyway, I'm going to offload the work of printing just the basic address information all on one line. Notice I left the label for home out because when I'm printing an address, I don't know what kind of an address it is. I just know it's this basic address information. So I need to also then refactor this code because now I need to do a what is this problem. So what is S? Well, in this function, S is nothing. It doesn't exist. So what do I have to work with? I have addresses. All right, so I don't have anything. The concept of a home address goes with the student. So that goes. So where do streets come from? They come from addresses. So this A address, I can kind of simplify the code if I do this because now I can just go straight from the address to its fields. So A, which means I can probably bring these things up to the line above, and that's just a little bit cleaner. So now I have a method for the address part specifically where it makes a string version of itself. So how do I use that in the student? Well, I can get rid of all this junk. And I can simply print the home address and then insert the student's home address call to that method. So student address method, which goes and produces a string and plugs it in here. So yes, this is intimidating at first. These sort of chains to get to the data that you want, and these sort of questions like what is this and where did it come from, takes practice. So hopefully it helps with just me, talking a lot through the process. But now that I have that, life is a lot easier because the mailing address, I can just use the same to string, but on the mailing address instead this time. I'll just say mail. Is that the whole? But yeah, that's everything we have. So then I can return that output. So this is kind of often what these nested or composite things will do. It's kind of every piece will do a part of the work for itself. So I have the student getting its own name and ID, but then the student goes and uses the home address's ability to get a string of its information. Same for the mailing address. And then I return all that output is everything that we know about a student. So now let's go down here and try it. So we are going to try it. I'm just going to say %s. Maybe I'll put a new line above it and a couple of new lines below it. And then we will say student1 dot toString. And then a whole bunch of magic happens. If we go study what student1 dot toString does, it plugs in its name and ID, and then it actually goes another layer and gets the address to plug in all of its information. This at first seems very, very difficult, but as you gain more skills and experience, you will discover that this is actually way less difficult. Once you learn how to think in these layers, it becomes less difficult to write more complicated code because we can break off pieces. So I've simply broken off the part of the printing code that produces addresses. And because I broke the address to stringing part off, that's made it very easy for me to get a string for the home and the mailing address and connect them up to everything I want to show about a student. Let's see if it works. And let's see also if it doesn't look terrible. There's an extra new line after the home address. I'm not really happy with that. I do have a problem here. The apartment number, I must have put it in as an integer and it's a string. Yep, I did it twice. So again, I have a mistake twice, but they come from one place. So it's one fix to address two mistakes, and then I have too many new lines going on. So new lines, new lines, new lines. Yeah, I'm going to take this new line off. So I'm in the address now. I noticed that the apartment number was broken. That's supposed to be a string. And then I took the new line off because too many new lines were coming out. If you look at this screen below, I want all of that information bunched up. All right, so all I had to do actually was fix the address to string part, and the whole output now gets fixed, which I am happy about. Notice, by the way, I don't know if you noticed, but University Avenue is all caps, as we had attempted to do. So anyway, what I believe to be very cool stuff. Nesting structs. So I'm going to keep building on this same one. So the sort of downside, the upside for you is that everything that we're doing that's new is going to be in this one example. The downside is that it might start to feel intimidating because so much stuff is nested in so much other stuff. So what I encourage you to do when you read through this example and experiment with it by making small changes, hopefully you're in the habit of doing that. But anyway, just move through the code and ask those kinds of questions. What is this? Some of them are easier than others. So right here on line 8, what is address? It is a struct, which is a custom type that I am creating. What is street? It is a string. What is apartment? It is a string, and so on. Down in this function here, if I just pick a spot, like what is A? I have to go figure out what is A referring to. So I look around and I'm looking for where A tells me what kind of thing that it is. Here it is. A is a pointer to an address. Does the pointer really matter? No, it doesn't. So really I can just think, well, A is an address. So what is A dot street? Well, if A is an address, then I have to go see what addresses are. Here's what addresses are. They're a struct. Street is a string that's a part of an address. So A dot street is a string taken as a whole, right? A dot apartment, also a string. A dot city, also a string. All right, so let's go through the process again, and let's build out the student record here. This blank line, by the way, in student doesn't have to be there. I just put it there so that the separate pieces are more apparent. So let's make this student record even better by associating course information with a student. Okay, so we could do this. We could say we could have a course name, should be a string. We could have a course number, which at Butte College would be a string because it's got weird characters in it sometimes. We could have a start time. We could have a days, which for now we'll just list as a string, like Monday, comma, Wednesday, comma, Friday kind of thing. We could have a start time. No, we could just have times. So 1 p.m. dash 3 p.m. So this would allow us to associate a single course with a student, but we already know that it might be a good idea, and we can even sort of more quickly imagine here that a student record may be associated with more than one course. So time to make a new struct. So let's make a course, and then we will put all this information. We can simplify once we're inside the struct. Well, we don't have to say course name because we already know that this particular name is part of this course struct. The number, part of a course, the days, part of a course, the times, part of a course, all strings. So not super interesting information, but now we can associate courses with a student. But pretty quickly, hopefully you can go with me on this line of thinking. I don't know how many courses a student might have at any given moment. Could be none, could be one, could be 3 or 4, could be more if they're particularly aggressive. So listing out the courses this way is not a good idea because it doesn't allow me to scale the information to match the student record. Far better would be to create a slice of course, and then I can simply append whatever courses I need to append to that student record. So here is a slice, which is another part of the agenda. Here is a slice, not an array in this case, a slice that is a part of a struct. Okay, so let's go do all the things that we have to do to make a course work inside of a slice, inside of a student. So here's a what is this question. What is this? Courses. It is a slice of course. What is course? Course is a struct with these fields in it. All right, so let's go give the student a course. Why I didn't, let's change that word. I don't like that word. Let's call it course list. So course list is a slice of course. That'll be easier to keep track of when we see it on the screen, I think. Okay, so course list. So what we are going to do to it is we are going to append a new course to it. And let's look at the different ways that we can do that. So how do we append a course list to a student record? Well, we can make a course and then populate it with data. Actually, is that always an integer that way? Do we have A's and B's? I better leave it like that just in case. I think occasionally we do attach a letter at Butte College. So technically that's probably an integer, but I'm allowing that we might have like a course called 10A or 10N or, you know, something weird like that. Number, days, we'll say Tuesday. Let's shorten it. Tuesday, Thursday. Times, let's say, so the reason I put it in a string is because I wanted to kind of just get all the data in there. The problem with the string, by the way, is that I can't, it's very much more difficult now to do manipulations on this data potentially. So I can't do math with the course times if I've stored it as a string. But for our purposes, that's fine. We just want to be able to see it. So let's say like 8 a.m. to 9:20 a.m. So there's the times. And then I can append course 1 to the student's course list. Let's go see. Let's go update our student to string so that we can at least see how many courses they're enrolled in. So we're going to go to the student to string, and we are going to I'm going to put an extra new line right here and say I'll say enrolled in some number of courses. And then a funny thing here, because I'm going to have to get the length of a slice. So how do we do that? Well, in the context of this function, now we kind of have to go the other direction. So do I have a slice in this function? I do not. So what do I have to work with? Well, really, it's the student record and whatever comes along with the student record, which would be the name, the ID, the home address, the mailing address, and the course list, which is a slice. So I know I can get the length of a slice if I can just get myself to the slice. So I got to start with the student. How do I get to that slice? It's the student dot their course list. And I can at least print out how many courses they are enrolled in. Okay, now the reason I did that is because I want to print the student before they have any courses, and then I want to print them again after I have appended a course to their course list to see if it goes from 0 to 1. So I'm going to print after I get all the addresses set up, and then I'm going to make a course and append it to their list, and then I am going to print out the newly updated student record, which hopefully shows that they now have, what did I call it, courses list? Line 79, I did something wrong. Oh, goodness gracious. So the error is right here on line 79 that I'm getting. It says undefined course list. So here's another what is this? Well, what is this and why is that a problem? What is course list? If I go looking around for the definition of course list, I will discover, oh crud, course list is inside of the student struct. So I can't use a course list unless I have a student. So now I get the student to get the course list associated with that student. And now the problem is fixed. And now we will see, initially I'm enrolled in 0 courses, and then I am enrolled in 1. We can also do this, by the way. Just going to copy that. So another way that we can append a course is we can append it in place. So we can do one of these things and append the course directly in place. Which we go for p.m. to 5:30 p.m. roughly. So I can also sort of create a course right at the moment that I am appending it into the course list. Now I'm not printing that information yet, but I should be enrolled in 2 courses now, and then we can go on to the next step. So this is working with a nested struct that I have placed inside of the student. Okay, so I'm actually going to do, before I work on anything else, I'm going to separate the code out. So this is another one of those things in a class like ours where we don't really need this technique, but I want you to have been exposed to this technique because you will someday want to use this technique if you continue doing programming work. And the technique is, can I separate out just the student part of the code from the program itself? And the answer is yes, I can. So I'm going to make a new file. Hopefully this works. I'm going to make a new file. I'm going to call it student.go. And then I'm going to take all the code that was the student stuff out of the program and move it over there. So taking all this code. So notice the only thing that's left is main and the import. I'm going to go over to student. I'm going to paste all that code in. So what I'm doing here effectively is I am making a student record library, a reusable library of code to represent a student record for a software system. So anywhere else that someone might want to make use of my code that represents a student record, I can just give them this file, give them a copy of this file, and now they can use my code without me having to go dig around in my actual main application. So now I just say, hey, here's a copy of student.go, use it and enjoy it. Okay, so student.go. The other thing I need to do is I need to make sure that the student code is in the same package as the application code. So the application code is in package.main. So in the student code, I'm going to make sure that it is also associated with package.main. So in theory, it should just work the same. I hope that it works the same and I haven't made a mistake somewhere, but as long as I, in the student.go file, say that this is going to be a part of package.main, and in main.go, the application is part of package.main. Oops, student needs format. As long as they're in the same package, then the code will just work. So this is another one of those things that can be confusing because now answering the what is this question requires an extra step. What is student one? It's a student, but there's nothing that tells me what a student is in this file. But I have another file that, handily enough, says student in it. If I go over there, I will scroll down and discover, oh, here's what a student is. Okay, so now we have the application, and this does require the burden on the programmers that I kind of have to switch back and forth to make sure I remember what the student code actually does when I'm developing my application. If you think about it, we've been doing this all semester with FUMPT and strings and math rand and time. We sometimes have to go read the documentation to see what that external file does. So now we have our own library. We don't have to import it. We just have to make sure that it is connected in code to the same package main, and it works. All right, so next step. I would like to print out not just how many courses, but actually the information about the courses themselves. So I'm going to do it the right way from the start. So how am I going to do this? I am going to loop through. I'm going to range loop over that student's course list, and then I'm going to connect to the output. Each individual course from the course list. So this C, this is another one of what is this questions. What is C? Well, it first appears right here as a part of a range loop. So the C in a ranging over course list is one course at a time. The purpose of the range, remember, is to start at the first course in the list, do something to it, and then repeat on the next course in the list, and then repeat on the next course in the list until there are no more courses. If there are no courses, then this never happens anyway. So what I really want to do with C, though, is I'm going to go ahead and offload the course information printing to the course itself via a toString method. So now I have to go to the course and make this method so that I can use it. If C is a course, then I need a method toString for courses. Here's course. I usually put the methods for the course right near the course. So function, this one is going to be a receiver that is a pointer to a course, because pointers eliminate the problems that occur when you needed one but you didn't have one. And now, so for me anyway, and this is what I hope that you experience at some point sooner than later, all I have to worry about right now is how do I get the information for a course into a string, printf. I don't have to worry about the student. I don't have to worry about addresses. I don't have to worry about func main. All I have to worry about is how do I turn the information for a single course into a single string. So all I have to do is look at the course and format its output. So I'll probably have the name followed by the number. And then maybe in parentheses, I will put the meeting times. And then because I think it would look fun, I will put an arrow in there, close the parenthesis. Name. And then the fields are going to be the course name. So that's C, which is a course. What is this? It's a course. Name is a string in the course. The number, the days, and then the times. And I have a nice, so that's all I worried about is how do I make a course into a string? And then in my student printing, I didn't worry about how do I make a course into a string. I just said, you know what? I'm going to make myself go do that separately. That way in my student printing, I can just say, well, whatever I did with courses to strings, that's handled in a separate piece of code. Do I want the numbers? I think I do want the numbers. I'm going to put that I back in there. So what is I? It's an integer. What does it represent? The index position of each course. They come as a pair, the index and the course at that index. But I'm going to go ahead and put that number here in the output and do the little +1 hack so it looks like when it's 0, it looks like 1 on the screen. Let's try it. Yep. So the first time there are no courses, so nothing appears, but the second time there are courses and they appear in a handy list. So your challenge in reading my code samples here is to unravel all of this mystery with a lot of what is this and where did it come from kinds of questions. So for me anyway, it was enormously helpful for me to take the time to do this when I was learning how to program like this. I just kind of forced myself to look at the code and ask, what is this? What is this thing? For all of it, what is output here? I have to kind of figure it out based on the context, which is a great way to read and study other people's code, but it's very helpful then when you have to write your own. Okay, and then we have the separate student code from the application code. I haven't even touched the application code in a while. Couple more things just to show you. So I can do this kind of thing. This is another just kind of a, what is this? Experiments. And then we'll call it good on this and we'll look at the lab. So what is this experiment? So student 1, that's a student. So I'm going to start with the student and I'm going to kind of dig down into the student struct and get data out of it. So how do I do that? Well, I use the dot notation. So which part am I interested in? I'm interested in the course list that goes with that student record. So now I have a larger what is this? What is student1.course list? It is a slice of course. So this is a slice of course. I want to get to the first one. So this is how I get to the first element of a slice. So given that student1.courseList is a slice, if I use square bracket 0, that is the first course in it. And if I go to the first course in it, that is a course. And if I get the name out, which I can do, that whole thing taken all together at once is a string. That is the name, which is a string that is inside of the first element of the course list, which is a struct, the first element being a single course, which is a part of a student record. So that is an example of a what is this kind of experiment that you might run for yourself. So it's a string. And knowing that it's a string, I can finish the experiment and confirm that I understand what the heck is going on here by trying to print out as a string that one piece of information. It's one piece of information that's embedded inside of a student struct, inside of a slice, inside of a course in that slice. Do I find the string name? And there is history. That's what it was supposed to be. So this is a way for me to kind of play around in the code and ask myself, do I understand this? Was I correct in digging down to get that name out of there and then knowing that it was going to be a string when I wanted to print it out? And the answer was yes, it was. Okay, so that's all of the stuff on the new content menu. So I will, let me do it right now like I always do. Put that. So make sure and put it on the lecture page. So it will be on the lecture page for you so that you can go look at these examples like I always do. Okay, so that is potentially, I don't know, it's only 50 lines of code is the student library that I created. But it's some intimidating code because we have 3 structs. Each one of them has a method. They could have more methods if I wanted. Each struct has a method. I just did toString. And then the student one is the most interesting one because it has it nested inside of it 2 address structs and a slice of course structs. And then the application itself is where I showed how do you actually use all this stuff. There I create a student, give it some data. I create an address. I write that into the student's home address. And then for the mailing address, I accessed the mailing address fields directly through the student, through the mailing address, which is why you see 2 steps. Then I used the slice. So I did 2 different ways of the first way, I created a course, I populated it with data, and then I appended it to the student's course list. The second example, I didn't create the course separately. I just created the course right in the place where I was appending it. So we called this, by the way, on line 43, that is called an anonymous instance. The course has no label associated with it specifically. It is created and then put immediately into a slice, and that's the only place where it exists in the program. And then I made sure that my toString on student worked, which includes printing out nested content. And then finally, I just kind of gave you the idea that you might try some what is this experiments for yourself. Okay, there's that. Now let's look at the lab. So I am purposely creating it now so that you can see the steps because the lab has an extra file in it because it does that separate code thing. So this is the lab for week 16. Let's go get all of the parts. So you'll notice on the lab page itself, we have a main.go, we have a shop.go, and we have a main test.go. So we have 3 files. And I'm going to go grab them individually and put them in there. So here's main.go, which doesn't have much in it, thankfully. There's main.go. Get rid of that one. There is a shop.go. So I need to go to my REPL and I need to make a file called shop.go. And then I will go get the shop.go code. Shop.go. So I just need to be careful here. So main has the lab tag at the top of it, lab 16. Shop says item and shopping list at the top. And then I know I'm also going to need a main underscore test.go. Still a couple of people not spelling that right. I'm not sure how else to get you there. Main underscore test.go, which is the way, of course, I always do it because it's the only way for it to be correct. It's also printed that way on the lab page. And if you have doubts, there are instructions on the guides page, but there's a link to instructions of how to do main underscore test.go. So me telling you, me showing you, me telling you and showing you in the guides page and linking it, that's all I can think of. If you're struggling with getting this file right, 99% of you have no problem. So I'm just saying this for the couple of people who keep making that mistake with main test.go. Just all I can say is you need to pay close attention to what you're doing. So main underscore test.go. All right, so what does my lab 16 REPL look like? Main.go with the lab tag at the top. Documentation is required. I'm forward dating it, even though I'm recording this a couple days early. This is what I would have put if I were there live on Tuesday night. Main underscore test.go. I'm going to go to the top to that. Doesn't ask me to do anything, so I won't touch it. Shop.go also wants me to document it. So there's two places to document. And I just did it by reading the instructions. So please pay attention to that kind of stuff. Okay, so what else? Where do I work? Well, I never touch main underscore test.go, so nothing there. Let's see what lab the main file says. You can use main to experiment as you implement your functions. Then do a pass. So have to pass the unit test. If I'm in doubt, by the way, I can go back to the lab and see what the requirements say. Document the code. Tells me here again that documentation belongs in main.go and shop.go. If I do any program output, I should make it neat. And then finally pass unit tests. Okay, so that's the big one, is passing unit tests. So it doesn't say, there's nothing here in main that has numbers or instructions or anything, which means it's really just there to allow for experimentation. So where's the work I got to do? It's in shop.go. It's all empty. If I were to run the program now, it probably wouldn't compile. If I were to try to test the program, it may not compile to be tested. Yeah, I just get too many errors and it quits. So I've got work to do. All right, here we go. So the struct itself is empty. There are instructions here, so I'm going to follow them. Represents an item in the shopping list. It needs fields, a description, and it capitalizes it, so I'm going to do the same thing. Tells me it needs a quantity. Capitalized, so I'll do the same thing. That's an int and a price per item. Camel cased and capitalized, which is a float 64. Great. I might just click run from time to time just to see if I'm getting anywhere closer. It's grousing to me about fumped, but we'll see. I bet I need to use that. All right, so there's the item struct, probably complete. The shopping list, it has some things in it. Has a label, which is a string. It does tell me what it's going to be used for. So shopping list represents a shopping list, shock, with items, shock. A label can be used to personalize the list. So we could have, for example, an application with more than one shopping list in it, my Christmas list, my grocery list, or associate the list with a specific store or occasion. So my Target shopping list or whatever. So label, which is a string, and all items, which is a slice of item. We've just practiced this. So we are nesting a slice of item, which is this guy, into the shopping list. The name of the slice in the shopping list is all items. Okay, so now we're doing some things that are repeats of last week. New shopping list returns a pointer to a new shopping list with the given label and no items. All right, so let's see if we can remember how to do this. We want to return, so we want to make a shopping list, so we're going to use this technique. We want to get this label inside of it. So let's see what happens if we put the label inside of it. And then we'll see if we get errors, and we'll talk about what I did wrong. So if you're watching me, even though you might be live, but I'm not live, you might ask yourself what I'm doing wrong, because I am doing at least one thing wrong. Imported and not used, fumped. I'm going to ignore that for now. Cannot use, so from line 32, it's right there on my screen, cannot use shopping list typed star shopping list. Yes, that's right. So I remember from last week that we are making everything be a pointer, including this moment of its creation. And the way we make this struct into a pointer to a struct is with the ampersand symbol. So let's see if it'll take that. Okay, so now I'm getting a too few values in shopping list. Oh, that's true. Because shopping lists are not only labels, they are also items. But I don't have any items. So what do? Well, it turns out in the Go language, I don't have to provide all of the information if I tag the information I'm providing. So for the capital L label in the shopping list struct, I am providing the little l label, which is this parameter. So if I tag the data, then I don't have to provide all of it. So that's handy. I just kind of ignore the items because I don't have any anyway. And now it looks like I'm getting closer to compiling. I'm not going to test until I get past this error down here. Great. Okay, adding an item to a shopping list. Checks first to see if the item is already present in the shopping list. If the item is not present, the item is appended to the list. If the item is present, then the quantity of the item in the list is increased by the quantity of the item passed as an argument. So this sounds scary. So I have to do a bunch of what ising right now. What is S shopping list? That is one of these things. All right, so it has a label. Doesn't appear I have to worry about that. Something to do with the items, all items in the shopping list. Add items, the name of the method because it has a receiver. So the parameter, what is this? What is item? What is I? I is an item. What is an item? It is one of these things. It is a thing that has a description and a quantity and a price per item. Fair enough. So this is a thing with a description, a quantity, and a price per item. It's also, by the way, one of the things that goes in the all items slice. So fundamentally, what I want to do is take the shopping list, access its items, and update it by appending this given item to it. So that seems okay. Except for it tells me I need to make sure that the item isn't already present. Now it happens that as I'm looking at the screen, I just saw something that might help with this. I should not do this append if this item is already present. If the item is present, then I'm supposed to update the quantity of the item instead. Oh, crud. But it doesn't tell me anything about how do I figure out if the item is present or not. How do I do that? But I see right on my screen that in fact, I have a method down here called hasItems that tells me true or false whether or not an item is present. I haven't even looked at the notes down here. All I know is oh wait, there's going to be, soon enough, a method that tells me true or false whether or not an item is already present. How does that method work? I don't know, and right now, I don't care. I just know that, oh, thank goodness, there's going to be a method that will do that job for me. So I'm going to use it here. If s dot has item I equals true. So good enough so far. So if the item is already present, then I need to update its quantity. List. Then the item of the quantity of the item in the list is increased by the quantity of the item passed as an argument. Okay, so I'm going to put a note here. Because I don't know how to do that just yet. So, but I do know I'm going to have a method soon that allows me to check inside of a shopping list to see if it has an item. So is this item in this shopping list? If true, I got to do something to update the quantity of the item that's already in the list. Otherwise, I simply append the item to the list. All right, so this updating the quantity of the item in the list, I think it might help to do this has item first and see if I learn anything about how I can get 2 items in the list. So let's try it that way. So we have this note here, add item. I need to come back to that in a moment. Let's go to has item and implement it because it has some instructions about how that works. And I can use that to not only implement has item, but hopefully come back to add item later and solve that problem. Has item checks to see by description. Got it. By description. Okay, so when I create a zeroed out bool, it's false. So as it is, I'm assuming that I will not find the item being present because I create a false bool and then return a false bool. But in between, I'm going to cycle through all of the items in the shopping list and see if I can find an item with a matching description to this item. Okay, so how's that going to work? Range loop. I don't think I'm going to need the index. I'm just going to need the item. Now, unfortunately, I've already used the I as the parameter, so I need to use something else. I will say IT. Range over the shopping list's items. Another kind of what is this moment. How do I get to the shopping list items? I use the shopping list dot and the name of the slice. So now I will cycle through all of the items that are in that slice. And then simply I'm going to compare the description of each item in the slice with the description of the item that has been passed to the function. So the IT is an item inside of the list. If there's an item inside of the list that has a description that matches the item I'm checking against, then the item in question is in fact present. And I no longer need to look. So I can break out of this search loop at that moment because I've found the match. But it's also the case that I think this loop is going to help me with the other problem. So I'm going to use the same loop, knowing that I'm really meant to be matching on descriptions. So I'll leave the note and I will use the same loop. And what I will look for is an item in the list whose description matches this item that I'm either going to update or append. So if I find an item in the list already with that description, then I don't want to append that item. I want to update that item. So now I face a problem because I need to update an item inside of the list itself, which means I got to use inside the slice. So I'm going to have to access an element of the slice, which means that I'm going to need the index that goes with each item. Now I still have this challenge that the I is already used. So I'm going to just say IDX for index of the item here. Just kind of shorthanding it so it's a little bit easier to type. So once I've found the matching item description, I also have access to the index, which means I can go into the slice. So now we have a what is this moment. What is this? The shopping list, dot, the slice of items. If I index into the slice of items, I get an item. And if I have an item, I can use a dot to get to the quantity of that item, and I can increase it by 1. So a lot of this, the content in the lab this week are for exercising your brain and being exposed to sort of the next level of how we use the tools that we've been learning. For Project 4, you do not need any of these techniques. You are more than welcome to use them, but they're not required. You're required to have a struct and have at least 2 methods, but you don't have to do any nesting of structs inside of structs, and you do not have to do any slices inside of structs, but you are more than welcome to do so. If you feel comfortable or want to have a go at it, you are welcome to do that. So you can, but you don't have to. Okay, so anyway, there's a long walkthrough of that whole process. Let's see if we compile yet. All right, so we still have a FUMP to go in, so let's keep going down, and let's just hope that we're doing all right. Actually, let's try the test and see if we pass anything. No, I'm still getting a grouse about the FUMPed use and not. So we're going to have to keep going and see what happens. Increase item quantity. Locates an item in the shopping list. Increases the quantity. Oh, by the quantity in the given item. Ooh, wait, did it say that up here? It did. Not by 1. If the item is present, the quantity of the item in the list is increased by the quantity of the item of the argument. So not 1, but the argument's quantity. Tricky. So this guy's quantity is what we add into the quantity of the item that's already present. It may not be 1. It might be 2 or 10 or whatever. But I'm stealing this from myself because increase item is the same code. Something's wrong here. Uh-oh. Uh-oh. Why is it not? I just want this to, there we go. Shift tab, I was doing control tab. Okay, so this is interesting, by the way. So I have the same code, the exact same code that loops through all the items, finds an item of the matching description, which it even tells me in the increase item quantity, that's what it's supposed to do. Increase the quantity of that item by the quantity in the item given. Well, if this is the same code, like literally exactly the same code as this, I don't need to duplicate the code. So in adding item, I will just say increase item quantity. I will let the other function do it. And I have a much cleaner function up here. So if the item is already here, I have a function to increase its quantity. If it's not here, then I'll append it. So has item is another method that does the work of finding it for me. Increase item quantity, which is what I'm supposed to do here, is another method. So I don't need to duplicate the code. I'll just use my own methods from in my own other methods to solve the problem. Make sure that we're getting closer. Still not using FUMP. That's okay. To string. Okay, so we've got some work to do here. To string returns a string representation of a shopping list. So we've already done something like this, have we not? Equals FUMP.s print F. So I have to do a label followed by a colon. So the shopping list label followed by a colon and a new line. So shopping lists label. And then I'm going to range over, and it looks like I need the numbers here. So I'm going to need the numbers. Let's do it IDX and IT equals range over s dot all items. So I've gotten used to running this range loop now. I do need the numbers because that's how I'm going to get the numbered list to come out. So range over all items, so I will get the index for the number part. IT gives me access to the items data from each item of that slice. So I will output plus equals, and then I'll do a formatted string. So I need the item name followed by a comma, followed by a space, followed by the quantity, which is an integer, space, at, space, $, 0.2f because it's money. New line, I suspect. We'll find out. Each. Supposed to say each right here. The name, followed by the quantity, name, comma, space, quantity, space, at, space, $, %.2f to get the price to 2 decimal places because it's money, space, the word each, new line, and then I'll put the items data. So the items name, the items quantity, and the items price per item. So you notice how it wrapped, which looks terrible. So the nice way to do that is to break all of that list down to the next line, which cleans it up dramatically. And before I forget, make sure I return all of that output that I created. Let's see if we compile. it.name, what's it called? I better look at the item. Description. Darn it, description. It's the description. IDX declared, oh yeah, I forgot the number. What a dummy I am. I forgot the number. So the first thing needs to be that number faked to make it look like one more than it actually is. I forgot about the number in the little parentheses there. All right, let's see if we can now run. Okay, so there's some outputs. There's a list. Let's see if we go test yet. So I'm passing 1, 2, 3, 4, 5, and I'm failing 2. So last thing, because I didn't implement this function, returns the total cost of the items in the shopping list by calculating the sum, which is the quantity times the price per item of all the items. All right, so I need a bar total cost float 64, and then that's what I'm going to return. And then I'm going to have to loop. So I'm going to have to, I don't think I need the numbers this time. I do need the items range over that shopping list items. So I'm going to build up a total cost, which is what the plus equals doing, by multiplying the items quantity times the items price per item. I know I have a mistake here, so if you're in chat, you can sort of ask yourself, what's the mistake about to happen? There's a mistake. So quantity times price per item, mismatch types, int and float 64. Well, I need a float 64 to come out. And if I look at item, the struct, I will notice that the quantity is an int. Well, crud. Price per item is fine, but the quantity is not. So I am going to have to floatify the quantity to get this to work. And then we will test. And now we pass everything. So I'm going a little bit long, but it's a challenging lab, so I wanted you to have a chance to walk through it with me. That's everything. You've just seen everything for the whole lab. So I won't share the link directly. That will be my hope and expectation that you watch through to the end of the lecture video to see the whole lab solution. All right, so we're going a little bit over. One last thing, which is the project. So let's go pull up the project. The easiest way, I think, to get to it, you can go to the reminders page, but it's also down here on the home page. Project 4. And I'm going to bring up another document. So I'm going to do a little bit of pseudocode for you. And what pseudocode is really just kind of mostly just handwritten notes to oneself, but maybe a little bit of code where it's needed. So pseudocode is really a way that we can design or prepare for implementing an application without actually worrying about how to actually code it. We use pseudocode to kind of just begin the process of preparing an application. So if we look at the project, we already know what the requirements are. We have five items. So I'll say notes and maybe pseudocode. So 5 items, and we're required to use a struct. So for me, struct possibilities here. Item plus the fields representing so what would an item need? It would need a name, a quantity, and a price. Hint, hint, we just did some of that. So that's one possibility for a struct. Another possibility is the cart. Which is kind of hint, hint, we just did something like this, which you could put a slice of item in the cart if you wanted to. You only have to have one struct. So the cart is the next level stuff, and it's more challenging. Not that the item part isn't challenging, but you need a struct. The most obvious one is to use a struct to represent the 3 pieces of data that are associated with each item. But if you wanted to, you could create a shopping cart where each time your person purchases an item, you either place an item in your cart or you update the quantity of that item that was purchased. So you get the idea. So that's kind of the setup. Method possibilities. Item to string. Item reduce quantity, right? Because every time they purchase an item, you want to reduce the quantity of that item by 1 until you're sold out. Item is sold out. Might be another possibility. You might have some cart ones, so cart, add, item, which may update, just like we just did in lab 16. Cart, total cost, We just did that in lab 16. So anyway, lab 16 has some of this code already in it that you could borrow. Anyway, just some ideas, right? So we need to be thinking of the requirements. We need at least one struct. We need at least two methods. So there are some ideas. Your ideas might be completely different, and that is perfectly fine. Do whatever makes the most sense to you, but if it helps, those are some ideas just about the setup in your code. So the main part of the program, what are we going to need? We're going to need a menu loop. So we print the menu. We prompt for a choice. So these are things, you know how this works, but it might just help for, I think it might help if I kind of just walk us down. So you're going to need a program loop that prints out the menu. We did this on project 3. Almost everybody had a program loop and a menu, but if you forgot how to do that, I did 3 examples with a menu loop for project 3. If you go back to the weeks where we were building up to project 3, I did menu loops. So you're going to have a menu loop that's going to have your items and also the option to quit. So you're going to scan, you're going to prompt for their choice. You're going to show them the menu. You're going to prompt for the choice. You're going to scan for the choice. If it's an item, see, how am I going to say that? Choice is item. Check that it's not sold out. If it's not sold out, then you'll reduce the quantity of that item and update your cart data, which is either a slice or possibly or just counters. So anyway, your cart could just be counters where you keep track of how many of each type of item they bought. But you could double up on your items. So you could have 5 item instances for what's in your store and 5 item instances for what is in their cart. So you'd have 10 item instances, one where the counters are going down and the other where the counters are going up. So that's one way to do it. But you could also just simply keep track as integer counters of how many of each item they purchase. So item 1 purchase starts at 0, and each time they purchase 1, then you plus equals 1 on it, and so on. So that's up to you. The counters is the most straightforward way to do it. Using extra struct item instances to manage that data is more challenging, and you might want that. So anyway, you need to keep track not only of the items in your store that are going down, you also need to keep track of what they have purchased with counters that are going up at the same time. So they pick an item. I want to buy this item. You first have to check to make sure it's not sold out, meaning is there any quantity left? If there are remaining quantity, then you can reduce their quantity, and then also at the same time make sure that you are updating your counters that keep track of the number of items that they've purchased. So you have 2 sets of quantities, right? What's in your store goes down, what's in their cart goes up. And then you probably want to print a message for them if the item is sold out. So if choice is exit, then you're going to go to a checkout phase, right? Now you can see this on the screen. I've done the same thing. I have a menu. On the first picture, on the second picture, I'll blow it up a little bit. On the second picture, you can see they have selected item 2. There was an item 2 in stock, so I let them purchase it. And you'll notice on the next screen that the quantity in the store went down, and then somewhere in my code, the quantity in their cart went up of that item. So they try to buy that item again. This time, that item is sold out, so I tell them that item's sold out. And then I skipped ahead in the sequence, so at this point, they have decided they want to check out. So I tell them how much they owe me. I did it sort of as pennies, kind of modeling what we did for project. Was that project 1 or project 2? Project 2, I think we did kind of the penny maker and the penny reducer. So that's how I built my vending machine or my little convenience store as pennies. So I called it credits, but I kind of say you owe me 300 credits or pennies, which made it possible for me to do the coins. If you want to, though, you can just say you owe $5.67 and then use floats. Totally up to you. So the checkout process needs to be a loop. Why does it need to be a loop? Because you need to make sure that they pay enough. You should not let them get away from your store until they have paid the full amount or above the amount what they owe. You need to know how much they owe before you enter the checkout loop. So now that you're in the checkout loop, you can so you can do it like I did in the example, which I did as like pennies or what I called credits, modeled on our project 2 from this semester, or you can use float 64 and just deal with it like you would any kind of normal money. All right, so they're in a loop. They're going to read their payment. Check to see if they have paid enough. If yes, then you can go to the receipt. If no, then the loop continues. So I'm just doing this to kind of help you if you're feeling a little bit scared about how to get started. A lot of you already, I suspect, kind of know everything that you need to do and want to do, so you can ignore this. If your flow is not exactly like this, that's fine. This is just kind of an idea about all of the problems that have to be dealt with. So finally, at some point, you get down to the receipt. And here you need to just sort of check the requirements. Check the requirements just to make sure that all of the required information is presented by your application. So mine has a receipt, shows the quantity of the items purchased. I did not print out the information about the items that they didn't purchase any of. So they bought 2 waters. They were 75 credits each, which meant that they owed 150 credits against the waters. Then the 1 soda, the 4 candies, their grand total. I've already collected their payment, so now I'm showing their change. And since I used the credits pennies idea from project 2, I was able to spit out quarters, dimes, nickels, and pennies, which I thought was just fun, but that's not a requirement. You can just say your change is 23 cents or, 0.23. Totally up to you. Okay, so that's it. That's what I've got. I will put a link to the REPL. I apologize again that this wasn't an actual live stream, that I have an obligation that I can't break away from. So I'm recording this a couple of days before you guys will see it. But as always, I am available by Canvas inbox. You can get help through Piazza, or you can schedule Confer Zoom time or the drop-in Zoom office hours on Thursday afternoon. So please do get in touch if you need any help. I hope you are having a good week and that you continue to have a good week. I hope you get a good result on the project, because it can be very satisfying to use the skills that you have worked so hard to develop over this semester on this project, which actually does kind of everything that we've done. This collects all of the skills that we have used this semester all in one place. So it's a great place to feel good and finish strong. Okay, I think that's it. Sorry again. I will see you on Tuesday, December 13th, which will be our final lecture of the semester for the C++ Bootcamp. It's not going to be a difficult week for you that last week. It is a chance for me to show you what C++ syntax looks like, so that you feel confident moving forward if you are going to the second semester programming class. Okay. Thanks for making it through this far. I hope that there is useful information in there. And otherwise, I look forward to either communicating with you in our normal channels or seeing you during the live stream or through this video, through a lecture video the last week of the semester. All right, take care.